Hi, my name is Eadom Dessalene, and I'm here to present Context in Human Action through Motion Complementarity at WACFI. I'm presenting this work along with Michael Maynord, Cornelia, Fermüller, and Yiannis Aloimonos, and we're all affiliated at the University of Maryland, College Park. So here's a conceptual illustration of our proposed framework where we model motion representations separately from contextual representations. We constrain these representations through the use of a contrastive loss formulation LMI shown between the two encoders. So the context encoder models representations of action complementary to the representations of movement produced by the Therbligs encoder, and together, by combining the two, we're able to more pertinently model the relevant aspects of action. So here are some example sequences. So our representations of movement are the Therbligs sequences shown at the Therbligs sequence row in each of the sequences, and each of the A, B, and C. So this Therbligs formulation comes from a previous paper of ours, where motion breaks down into the reaching, grasping, using, moving, etc. of objects. And we have the context-aware action as belongs to the Epic Kitchens dataset that at a high level includes the context that's not included within the Therbligs sequence. So this just shows the data. So here is our proposed two-stream architecture as it's trained against the various sources of supervision. So input video is simultaneously fed to our proposed Therbligs encoder and context encoder. The two streams are trained separately over different sources of supervision. The LMI term is used to, so the Therbligs encoder makes use of its own Therbligs ground truth labels and is trained first. After finishing training the Therbligs encoder, we begin to train the context encoder by training it against the representations produced by the Therbligs encoder using the LMI term, and training it to and also including the cross entropy of the action logits provided by the Epic Kitchens dataset and the 50 Salads dataset. So the final action prediction is arrived at by summing Therbligs representations and context representations at the very end. So here are some visualizations. During the second epoch of training, the left column, these two figures here, correspond to the representations produced by the network without the use of this LMI term, this mutual information contrastive loss term, and the right column of those two figures show our network with the use of the LMI term. So at a high level, the idea here is to show how the network understands actions that are very similar in movement but happen to involve very different contexts. So the washing, pouring, and mixing happens to involve different objects, but at the level of motion is very similar. So our network is able to much better separate out actions that are similar at the level of movement, very different at the level of context. Thank you very much for your time.